Okay, example 2, how reliable are mammograms? This is very, very much, what do I call this? In the news, right? Because of coronavirus and the testing and positive and negative tests, and there are things called false positive, false negative. So um, this is a good application, relative application of tree diagrams. So it says many women choose to have annual mammograms to screen for breast cancer after age 40. A mammogram isn't foolproof. Sometimes the test suggests that a woman has breast cancer when she really doesn't, which is called a false positive. Other times the test says that a woman doesn't have breast cancer when she actually does. That's a false negative. Suppose that we know the following information about breast cancer mammograms in a particular population. 1% of women aged 40 or over in this population has breast cancer. For women who have breast cancer, the probability of a negative mammogram is 0.03. For women who do not have breast cancer, the probability of a positive mammogram is 0.06. Suppose we select a woman aged 40 or over from this population at random. Okay, so right here, this is the first stage probability, having breast cancer or not. And then you have a couple conditional probabilities as your second and third bullet points. So let's fill out our tree diagram, and then we'll find the probability that somebody tests positive for breast cancer. Okay, so the first stage is the cancer stage. Do you have it or don't you? Okay, so has breast cancer, uh, does not have. So something like that. Whatever you want to do, it's up to you. Okay. 1% have breast cancer. That is 0.01. So 0.01 has cancer. So then that means 0.99. I'll do it down here. 0.99 do not have breast cancer. Right. That's good. Right. Unfortunate for the 1%, but that's good for the other 99%. And now we look at the second stage, and the second stage is going to be the test. And you can take a test and get a positive or the mammogram, right? You get a positive or negative result. And again, positive or negative result down here because there's two branches in the initial stage. So for women who have breast cancer, the probability of a negative mammogram is 0.03. Okay, so that's a false negative, right? That's not good, right? We don't want to have it and not be shown on the test. That's not good. So then there's a 97% chance that you have it and you do test positive, which is very good. Right? You want the test to show you that you have cancer. For those who do not have breast cancer, there's a probability of a positive of 0.06, right? So that's not great, right? You don't want to not have it and be told you have it. That's why whenever you go for like a major exam, you should probably go to more than one doctor just to make sure that they are correct. So then that'd be that 94% do not have it and get a negative result, right? Okay, so there's our tree diagram. So now we have to determine the probability that someone would test positive. So again, there are two tracks for positive here and here. So we must follow the has breast cancer and then test positive given they have breast cancer, and uh, the has or does not have breast cancer, and then test positive given they don't have breast cancer. Okay, so the probability of a positive is going to be the first branch, 0.01 times 0.97, plus the second branch, 0.99 times 0.06. I'm going to do that in a dinky calculator. I don't think you need me to show you again. 0.01 times 0.97 plus 0.99 times 0.06. And I got a positivity rate of 0.0691. And that's the probability that somebody would test positive. Okay? All right, good. Okay, so hopefully this video helped you set up your tree diagrams. If you have any questions on the homework, let me know.